All right, welcome to today's lesson on dividing decimals, and this is a little bit different from multiplying. So, we're going to have a look at a few problems, and hopefully we can get through some good learning. So here is a problem we're going to look at, and this one's pretty straightforward. 35.756 divided by 4. Now, I hope that everyone will have seen a division algorithm from primary school. What I'm about to show you isn't brand new. If it is, you need to let me know. All right, so the division algorithm looks like this, and we put the dividend inside the symbol, and we put the divisor outside. All right, so just to use some fancy words there, this part here is called the dividend. It's the thing being divided. This part here is the divisor. It's the thing doing the dividing, and the answer will appear up here, and it will be called the quotient, which is a little bit weird. Okay, so remember those, the three parts of a division problem. All right, now, in case you don't remember, division is about sharing, and this problem is basically saying 35.756 divided by 4. It's basically saying how many of the 4s are in that number. All right, so we need to know 4 times something is roughly 35. So we know that 4 9s are 36. 4 times 9 is 36. That's a little bit bigger than 35, which means the answer is going to be a little bit smaller than 9. So we expect our quotient to be around 8 point something, a decimal. All right, so let's get a move on and we'll have a look at the process. I'm just going to erase those 3 words. I would like you to remember them though, because they're going to be on the weekly quiz. All right, so without further ado, we say this. We say how many 4s are in 3? Obviously, none. We carry the 3 across to here and we write 35. How many 4s are in 35? Well, we know it's around not quite 9, so it's going to be 4 times 8 is 32. So I put 8 there, and I know that there are 3 left over from 32 to make 35, so I put the extra 3 over here. Then I say, how many 4s are in 37? And I know that 4 9s are 36, so I'm going to put a 9 there. And because 4 9s are 36, that leaves 1 left over from 37, so I put the 1 there. How many 4s are in 15? And that gives me, 3 with 2 left over. How many 4s are in 26? And that gives me, 4 6s are 24. So 6 up there. Just going to extend this line because sometimes we need to. Now we find 4 6s are 24 and I had 2 left over. But there's nothing written here. In which case what we do is we just keep putting a 0 in. So we put a 0 here. Now, how many 4s are in 20? And we find that it's an even 5. So here is our answer. 0.89365. But that doesn't make any sense because there's no decimal point. So this one, just like some of the addition and subtraction problems, we can put the decimal point above where it was in the dividend. So the answer is 8.9365. And that is approximately what we thought it was going to be. We thought it was going to be around 9, and it's 8.9 because 35 is just below 36, and 8.9 is just below 9. Okay, so this process we've just used is called short division, where I calculate how many of the divisor is in the digit and carry the remainder to the right, each time to the right. Okay, hopefully that's not a new process for you and you can remember it from primary school. Just in case, we'll do another problem together. All right, so this problem is 74.52 divided by 6. Okay, so again, we'll set it up with the division symbol, 74.52 with the divisor out the front. And we go through the steps. How many 6s are in 7? Well, that's 1, with 1 left over. How many 6s are in 14? That's 2 with 2 left over. How many 6s are in 25? That's 4 with 1 left over. How many 6s are in 12? That's 2 with none left over. And the decimal point is directly above the dividend's decimal point. So the answer we can write here is 12.42. Okay, and if you want to check it, you can say, well, 6 times 12, I know, is 72, and a little bit more because of the 0.42, the answer is 74. So that seems reasonable. That's a good estimate. All right, so those two problems dealt with dividing by a whole number, and now I'm going to show you a couple more problems that deal with dividing by a decimal. So a decimal divided by a decimal. All right, so we'll push those to the side, and we'll bring up two examples just here. So in this case, what we're allowed to do is similar to the multiplication problems. We're allowed to manipulate the numbers and sort of ignore the decimal points. So the question looks like this: 64.137 divided by 0.03. Now remember, it's how many of those are in here. And because that's a very small number, the answer is likely to be very large. So we can write it like this: 64.137, 0.03. All right, now what we're going to do is we're going to actually move the decimal point in the divisor to make a whole number. So if I put the decimal point there, it's now 3. But because I've moved it in that number, I also have to move it in the other number, the dividend. So I move it 2 places here also. So now my dividend is not 64, it is 6,413. But I'm dividing it by 3 instead of 0.03. So what I'm doing is I'm keeping the spirit of the problem there, but I'm changing the digits, or changing the numbers' values. Okay, so in that case, we just keep going. 3 into 6. How many 3s are in 6? 2. No remainder. How many 3s are in 4? 1 with 1 remainder. How many 3s are in 11? That could be 3 with 2 remainders. How many 3s are in 23? That would be 7 with 2 remainders. And how many 3s are in 27? That would be 9 and no remainders. And the decimal point just gets placed above the new decimal point. So the answer here is 2137.9. Now think back to the very beginning where we talked about how many of those are in this number. And this being a very small number and that being reasonably large, the answer should be quite big, and it is quite big. All right, so keep in mind, we moved the decimal point 2 places here to make the divisor a whole number. We followed suit with the decimal point in the dividend and moved it 2 places also. Okay, so the objective is to make the divisor a whole number and follow suit with the dividend. So let's have a quick look at another one, a very similar problem. It is 6.74 divided by 0.05. So again, we'll draw out our little thing, 6.74, 0.05, and I will move the decimal point 2 places to make this a 5 instead of 0.05. So I've got 5 there now. I will move this 2 places also, so instead of 6.74, it's 674. And then I will go through with my division. So how many 5s are in 6? That's 1 with 1 left over. How many 5s are in 17? That's 3 with 2 left over. How many 5s are in 24? That would be 4. And what happens when we have a remainder that we don't use? We can just put the decimal point here and carry zeros over. So 5s are in 24, that was 4 and 4 left over. And how many 5s are in 40? That's 8 and no leftovers. And the decimal point gets placed up there. All right, so a couple of pretty important things to remember from this lesson. All right, first and foremost, the short division algorithm has the remainders carried over to the right. If we run out of digits in our number, we are allowed to keep putting zeros in, so long as there are remainders and we want to keep going. Next lesson, we'll look at a few different types of decimals and discuss their properties to do with those zeros being placed in there. When we divide by a decimal, we change the divisor to a whole number or as close to a whole number as we can, but we also have to change the dividend by the same amount. So if we moved the decimal point twice, we do the same in the dividend. All right, so it's a long video today, but it's important, so give those questions a go. All right, in today's lesson, we're going to learn about two different types of decimals called terminating and recurring decimals, which will lead into topics like irrational numbers and things like that. This topic runs off last lesson's work with dividing, so make sure you've done dividing before you look at this lesson. All right, so without further ado, we're going to look at converting 1/2 into a decimal. Now remember that the vinculum, that line there, means divided by. So when we convert, we're just going to go, how many 2's are in 1? And we write it like this, 2, 1. Now obviously we know that how many 2's are in 1, there are none. If I have a remainder, or there's 1 left over because I wasn't able to divide it, we put the decimal point in, put another 0 on, carry the 1. How many 2's are in 10? The answer is 5. So there we are, we've converted 1/2 into 0.5, which we should all have known, I think. Now this is a special type of decimal called a terminating decimal. You can see that it just stopped. There were no more remainders, which means that we couldn't keep going out here, and it's just 0.5. Now what about another type of decimal called a recurring decimal? Now a third is a really good example of this. So a third we'll convert into a decimal. We'll go, how many 3's are in 1? 3, 1. How many 3's are in 1? There are none. Carry the remainder onto the next 0. How many 3's are in 10? There are 3. And there is 1 left over. How many 3's are in 10? Oh, there's 3 and 1 left over. How many 3's are in 10? And you get the idea. This process will keep going on forever. There is no stopping because I will always carry a 1 onto the next place. So the answer of a third in a decimal is actually 0.3. Now you might have seen it recently and you might have seen it in primary school. There are different ways we can show this, but I would put a line above the digit that recurs. All right, so this is called a recurring because one of or more of the digits happens again and again and again and again. So recurring means re-occurring. All right, so re-happening. So this 0.3, if I was to write it out in full form, it would look like 3, 3, 3, 3, 3, 3, 3, 3, and on forever. But I don't want to write them all out, so I just put one of them and then a line above it. Okay, so this is called a recurring decimal. So our two types so far are terminating and recurring. Okay, so the two very important types are like that. Now, if a decimal stops at all, it's terminating. If it keeps going forever and there's no end in sight, it will be called recurring. So let's have a look at another one. We might go 1 over 11 or 1 divided by 11. So we'd go 1, 11, lots of 1's here. How many 11's are in 1? There are none. Put another 0 on because I have 1 left over. How many 11's are in 10? There are still none. Carry the remainder. I have 10 remainders. How many 11's are in 100? Well, there is 9 because a 9 11's makes 99. And there is 1 left over. How many 11's are in 10? There is none. And I carry the remainder. And you can see a pattern emerging here. How many 11's are in 100? Oh, there's 9 with 1 left over. So you can see that the pattern here has gone, the remainder has gone 1, 10, 1, 10, 1, and you'd expect it to keep going. The decimal does the same thing. It goes 0, 9, 0, 9, 0, 9, and so on. So this is a recurring decimal of 0.09. But I can't put the line above the 9 because it's not the 9 that recurs, it's both of them. So I put the line above both of them to show that it's 0, 9, 0, 9, 0, 9 on into infinity. Okay, so that's another important lesson. We put the line above the digits that recur. Above digits that recur. Okay, so think very carefully about how you're looking at this and how you're reading the answer. So we might have a couple of examples just to give a bit of a go. So we're going to turn a quarter into a decimal and 7/8 into a decimal. All right, so pause the video if you want and give those a go, and then come back and have a look at the answer. Okay, so if you've come back now after giving it a go, you'll see that hopefully you've written something like this. 1 divided by 4. I'll put that in there just for now. How many 4s are in 1? There are none. Carry the remainder. How many 4s are in 10? There are 2, with 2 left over. How many 4s are in 20? There are 5, and no remainders. So this is a terminating decimal of 0.25. And that is the quotient there. Now for 7/8, hopefully you've given that a go as well. We've got 7 inside, 8 outside. How many 8s are in 7? There are none, with 7 left over. How many 8s are in 70? There should be 8, with 8 8s are 64, 6 left over. How many 8s are in 60? There should be 7, because 8 7s are 56, and 4 left over. And how many 8s are in 40? There should be 5 and none left over. So we have another terminating decimal of 0.875. Notice that in terminating decimals, there's no chance of it keeping on going because there's no more remainders. Okay. Now we'll have another quick look at a few others. We might have something like 2/3 or 3 5/7, and we'll have a quick look at how to do the 3 5/7 one. So pause it and give those a go, and then come back. All right, so hopefully you've given those a go in your own books. So we should have 2 on the inside, 3 on the outside. How many 3s are in 2? There are none. How many 3s are in 20? There are 6, with 2 left over. Oh no, how many 3s are in 20? There are 6, with 2 left over. This is like being stuck in a time loop. How many 3s are in 20? There are 6, with 2 left over, and so on. So this is a recurring decimal of 0.66, double R in there. 0.6, so we could write it as 0.6 recurring like so. All right, now how to deal with mixed numbers. Just like for addition, subtraction, multiplication, and division, we convert them into an improper fraction. So I have 3 times, or how many 7s do I have in 3 wholes? That's 21, and an extra 5. So that's 26/7. So I'm going to convert it into a division. So I have 26 on the inside, 7 on the outside. How many 7s are in 26? Should be 3 with 5 left over. How many 7s are in 50? There should be 7 with 1 left over. How many 7s are in 10? There should be 1 with 3 left over. How many 7s are in 30? There should be 4 with 2 left over. How many 7s are in 20? There should be 2 with 6 left over. How many 7s are in 60? There should be 8 with 4 left over. How many 7s are in 40? There should be 5 with 5 left over. How many 7s are in 50? There are 7 with 1 left over. How many 7s are in 10? There are 1 with 3 left over. And I'm going to stop right there because hopefully you've just noticed a pattern. If we look at the remainder of the first one, we have remainder 5, then remainder 1, then 3, 2, 6, 4. Then it started again, 5, 1, 3, and we'd expect it to go 2, 6, 4. So this is where the digit starts to recur in a pattern. So we can say that the answer to this is 3.71428 and then it starts again. So we put a line above all of that to show that that is the pattern that happens. Okay, so when we're converting into decimal, we only need to divide as far as the pattern restarts. So notice that it went 5, 1, 3, the remainder went 5, 1, 3 down here. So I don't keep going because I know what's going to keep coming. It's going to go 7, 1, 4, 2, 8, 5, then 7, 1, 4, 2, 8, 5, then 7, 1, 4, 2, 8, 5, again and again and again and again. All right, because there's always going to be a remainder. So hopefully that division process makes sense. All right, hopefully you understand what a terminating and recurring decimals are from this lesson and are able to recognize each of them when you're creating them. All right, welcome to our final video for the week. Hopefully it's something that you have seen, or maybe not, but not unfamiliar to you. It's on rounding decimals. How do you like my new pointer this week? It seems to be a bit of a lightsaber. All right, so rounding decimals is about writing them shorter than they are. So you saw last lesson how we had 1/3, which was the same as 0.333, and so on. All right, so sometimes we don't want to write all those digits down. We only want to write down 1 or 2 or 3 or another number of them. So we call that rounding. Now, rounding means that we're changing some of the digits because they're not, or they're too long. Okay, so we'll look at this decimal here, 15.35729. And let's say we wanted to round it to 4 decimal places. You can see here I've got 1, 2, 3, 4, 5 digits written afterwards, but I only want 4. So what we'll do is we circle the one we want and we put an arrow above the one we don't want, which is the next one to the right. Okay, so we circle the one we want, which was the 2. We put an arrow above the next one. So that's a 9. Now, we ask ourselves, is this one, is it bigger than 5 or is it smaller than 5? Or is it bigger or equal to 5 or is it smaller than 5? Okay, so 9 is clearly bigger or equal to 5. What that means is the number in the circle needs to change to a 3. Okay, 15.3573. Now the reason that happens is because if we look at these 2 digits, that's 29. All right, now if I chop off the 9, I can't say that the number is 20, because if I chop off the 9, that would basically be a 0, and that would read as 20. But 20 is not the same as 29. So what I should do, if I'm going to chop off the 9, I should change the 2 to a 3, so that the number I read there is 30, because 29 is closer to 30 than it is to 20. Okay, so the number now would be 15.3573. The only one that changed was the number we circled. The others stay the same. Okay? Does that make, hopefully that makes sense. So we'll have a look at another one. We'll go 4.86195082. And we'll round it to, let's say, 6 decimal places. Okay, so we go, well, there's 1, 2, 3, 4, 5, 6. So I want to circle the 0, put an arrow above the next number. Now 8, we can clearly see is bigger than 5. So we're going to change the 0 to the next number up, which is a 1, and leave all the rest of the digits to the left the same. And our new number is 4.861951. And again, if we look at the 2 that we looked at, so we have 08 you can see that 0.8 is closer to 10, because imagine there's a 0 here at the end. 0.8 is closer to 10 than it would have been to 0 if I'd left the 0 as a 0. So I changed it to a 1. Okay. What about if we used the same number? Oops, 8, 6, 1, 9, 5, 0, 8, 2. And instead of going to 6 decimal places, what if we round it to 2 decimal places? Okay, so we look at this, we go 1, 2, circle the second one, put an arrow above the next one. Is 1 bigger or smaller than 5? Well, hopefully you can see that 1 is smaller than 5, which means I leave the 6 as is. So the number is 4.86, and I chop off all the rest because I've written 2 decimal places after the decimal point. All right, now let's have a look. 61 were the 2 numbers I was interested in, and you can see that 61 is closer to 60 than it would have been to if I'd changed the 6 into a 7. It would have been 70. So 61 is closer to 60 than it is to 70, and that's what we've done there. We've left it as 60. Okay, so the rules for rounding are pretty straightforward. If the digit after the one you're chopping off is greater than or equal to 5, we increase that digit. If the next one is less than 5, we leave it as is. All right, so equals. So it goes up only if the next one is bigger or equal to 5, and it stays as is if it's less than 5. It doesn't go down. Okay, so hopefully you can apply that to some questions on your own, and let me know if you need any help.